Hi, I am Vladimir Tian, a senior algorithm researcher at Gibson Media. So first, what is GAN? GAN is an abbreviation of Generative Adversarial Network. It's an supervised learning technique that automatically discovers and learns patterns in the input data. Such the model can be used to generate new examples from the original dataset. GAN consists of generator and discriminator, which are trained simultaneously with different goals. Here, generator learns how to produce output to be labeled as a real by discriminator, while discriminator tries to learn how to distinguish generator's fake output from real. In this example, generator is represented by thief trying to produce fake money to trick police, and the discriminator is depicted as a police officer learning how to distinguish fake money from real. So now, let's begin with what is GAN in super resolution. GAN in super resolution is a training method that can increase perceptual quality by sacrificing distortion metrics such as MSE or PSNR. Here are the results from Param Challenge, a well-known super resolution contest. In the figure, you can see a trade-off relationship between perceptual quality and MSE. Esargan authors also proved the effectiveness of GAN in a very explicit way. SRSNet and SRGAN networks have the same topology, but SRGAN utilizes GAN training. As you can see, GAN maximizes MLOS score with the same size network topology. So, why is GAN so effective in terms of perceptual quality for SR? Traditionally, most deep learning based super resolution models are trained with averaged per pixel losses as a mean squared error. But MSE-based approaches tend to produce over-smooth results due to pixel-wise averaging between all possible solutions from the ground truth natural image manifold. On the other hand, GAN guides SR reconstruction towards the natural image manifold, resulting in much better perceptual quality of the produced output. There are examples of GAN impact on SR task from SRGAN paper. Original ground truth image is provided for comparison as a baseline on the right side. On the very left side, there is a result of a conventional bicubic scalar result. Take a look on the next picture. A deep learning based approach. You can notice that the overall quality and sharpness are much higher. SR has the same size network as a SRSNet, but it's trained with GAN technique. It produces the best perceptual quality and reconstructs details compared to the other methods. Due to hardware IP max gate count and maximum number of network parameters restriction, the main challenge in applying SR network training with GAN is the network size limitation. As you see from this graph, all previously GAN trained successful networks like SRGAN or ESRGAN are very large. For example, the SRGAN network parameter number is 50 times larger than our hardware IP network parameter number. And let me briefly explain how we, Gibson Media, did it. There are a few things that allowed us to achieve competing results using GAN training on the network with a minimal number of parameters. First, a cost-effective topology with high capacity that maintains a very small number of parameters. Second, the unique training method that we have applied during GAN training. And we applied several data augmentations techniques to increase overall SR quality. This is our CWave 121 specification. CWave 121 is cost-effective super-resolution dedicated accelerator IP. It consumes extremely low DRAM bandwidth to support edge devices. It supports 8K 60 FPS at a 550 MHz clock. It supports 1 to 8 scale range with scale 2 and scale 4 networks. In terms of gate count and power consumption, CWave 121 is more than 20% effective than CWave 120. Now, let's compare the two images here. The left is upscaled by conventional upscaling method and the right is upscaled by our super resolution IP. On the left, You can see the fuzziness through the image. It's a bit blurry and the color isn't so vivid. But if you look on the right and compare it to the left, the peacock peak is shown more expressive without blurry, and the overall color is more precise. Let's take a look at one more example. Again, left is upscaled by conventional upscaling method and the right is upscaled by our super resolution hardware IP, C-Wave 121. See how the stitches are depicted more sharply. Overall visual appearance is much distinct on the right. All these are uploaded in our YouTube channel with other SR demonstrations.